Hello everyone, welcome to another tutorial. Today I would like to introduce you our new product. It's a combination of RF and AM system, the so-called AM-RF hybrid system. A system that many well-known manufacturers say that make quite no sense and can't be made at all. So in this video I am going to show you how a system that can be produced works. Let's get to it. AM-RF hybrid system. What is actually the reason to develop such a system? There are so many different systems in the world. AM and RF systems make up the largest part of the market. A smaller part is made up of EM systems and others. Let's focus here on AM and RF only. So there are many different systems: white, narrow, transparent, backlight, plastic, metallic. There is even larger selection of tags. Lots of shapes, with pin, with linear, without linear, plastic, paper. Everyone can choose. So why invent any combinations? Who really wants that? Many questions, few answers. Let's look at it in more detail. In an ideal world, the customer chooses the technology, chooses the system, chooses the tags and labels according to protected items. The supplier installs the system for him and the customer is happy. Unfortunately, we do not live in an ideal world. It sometimes happens that the customers are not completely happy. For example, he is not satisfied with the system. He is not satisfied with tags. This can be solved. We can change the system, we can change the tags. But what happens if the customer is not satisfied with the chosen technology? In this case, there is no simple solution, because there is no better or worse technology, but each technology is simply different. So the reasons are simply there, and the customers also exist. So why is there not a suitable system here when the demand is? Both RF and AM technology have a long history. RF and AM systems work well, so why hasn't anyone put them together a long time ago? Is there a problem here? Yes, there is obviously a problem here, but in my opinion, it is not a technical challenge. Of course, it is not possible to just take two technologies, somehow cram them into one pedestal, and then turn it all on. Well, it can be done that way, but the resulting detection will not be much good. Whether we like or not, both these technologies in one pedestal influence each other. Although the operating frequencies are far apart, their antenna loops are very close. The basic condition for proper function is that individual technologies must know about each other, that is, they must communicate with each other. Timing, synchronization, state of people counter sensors, and much more are important. It's a technical problem, but it is just a usual technical problem. But another, I would say, political problem arises from the communication conditions of individual technologies. Why has not a usable hybrid system been created yet? Imagine this. This is the entire EAS market. It's divided into two parts, AM and RF. If we want the best hybrid system, we should use the system of the best RF supplier, whoever it is. And we should also choose the AM system from the best AM supplier, whoever it is. I'm sure that these two suppliers can solve all technical problems. And now we tell them, guys, exchange information and create the best hybrid system. And I guess here is the problem. After all, everyone has their own know-how, both RF and AM supplier. This is very sensitive information. And besides, everyone has their customers and no one wants them to run away to their competitors. Imagine that a supplier of RF technology gives his customer the option to just leave for AM. It's better to say that such a system simply doesn't exist. So, such a system can only be developed by someone who can produce both RF system and AM system. Definitely don't expect this product from companies that are focused on only one technology. And therefore, I am happy to introduce to you a concept that works. And we developed it because of the need to have both technologies available in one place, in one pedestal, both AM and RF. The idea was simple: to integrate both technologies in the simplest possible way, so that a technician with existing experience with our systems can install them. We used CPP Plus 540 pedestal, which is large enough to contain both RF and AM electronic boards, antenna loops and power supply. Since we don't have a problem with the know-how, the systems are interconnected and differ from standard systems only in the firmware version. The firmware is modified so that the systems can be set by a standard application via hardware key in simple cases or via the internet. And now I will show you how to set them up. Electronic boards are installed as follows: AM electronic board and power supply for both systems on one side and RF electronic board on the other side. Let's begin with the easiest configuration, which is a mono antenna system with local connection. We will need only a hardware key and application here. I remind you to always request the latest version of the application. We connect the power supply and connect to AM system using the hardware key. We will set up the AM system as usual. We will set the group ID to 0 and the pedestal ID to 0. All details regarding settings are included in our tutorial 1, 2 and 3. Here I will only note the differences from the standard setting. We will check settings of the external input. The RF system alarm is connected to this input. We can set different sound and light for AM and RF alarm. Light and sound for the RF alarm are set in the alarm's external alarm window. The timing of the RF system is controlled by synchronization of the AM system. It means we only set synchronization delay on the AM system. The RF system transmits in the same rhythm as the AM system. You may notice that there is a little interference from the RF system here. Let's test the parameters of the AM system. Then we disconnect from the AM system and connect to the RF system. We will set the group ID to 0 and the pedestal ID to 0. The system must be set to master mode. Let's check other settings. All details are described in tutorial 4. Next we will check settings of external output in the I/O setting window. The output must be set as follows. These are all visible differences from standard systems. More complex installations differ only in the setting and connection of synchronization and the setting of the corresponding systems in master or slave mode. Slightly more complicated is a mono antenna system with network connection. We will need one more cable. We will connect it to the AM-TRX LAN out and to the RF-TRX LAN in. In other words, we will connect the RF-TRX electronic board behind the AM-TRX electronic board. And, of course, we need to connect the cable from the router to the power supply. So, 2 extra cables. In this case, we need to change the RF-TRX system setting to group ID 1 and pedestal ID 0. The AM-TRX system settings will remain the same, group ID 0 and pedestal ID 0. If we want to connect 2 or more pedestals, the procedure is always the same. Correct wiring and correct group ID and pedestal ID setting is essential. To explain, I will use a picture from the manual for the hybrid system. In the picture, you can see the connection of the 4 antenna system. We connect the cables as follows. Firstly, you need to connect power cable to all pedestals. At the master AM-TRX pedestal, you need to connect synchronization cable from power supply to the master AM-TRX electronic board. Now, you are able to start working on this AM-TRX electronic board. Then you need to connect all AM-TRX board slaves. From master pedestal LAN out port, you need to wire LAN cable to the first slave antenna LAN in port. And the same way to all others AM-TRX boards. From the AM-TRX last slave, you need to connect LAN cable from LAN out of AM to the LAN in of RF. This RF-TRX board will be set as master pedestal for the RF-TRX boards. As I said before, because of the special software for AM-RF technology, pedestals will receive synchronization pulses from last AM-TRX and will correctly synchronize RF technology to the AM technology. Next step is to connect LAN cable between all RF-TRX boards, and all other RF-TRX boards will be set as slave. Also, very important is to install all pedestals oriented at one side only. When looking directly into the entrance of the store, all AM-TRX boards will be on one side, for example right, and all RF-TRX boards on the opposite side. It will reduce people counter installation issues, and also it can eliminate possibly poor detection of system. One note here, there is one limitation if you are connected to systems using a hardware key. Hardware key must always be connected to the system that is set as master. In the list of connected systems, we will always see only one technology. That is either only AM or only RF. This is because the technologies are divided into different groups according to the group ID, and only the systems of one group will be displayed in the list of systems. So let's see how the system works in real life. I'm gonna use a DR label for AM and a small tag and 4x4 label for RF. A few final notes. Expect a detection distance of around 6 feet for 4x4 RF labels. That's not the best performance of a 540mm wide pedestal, but remember that there are two systems inside, whose loops are balanced, so the loops can't be wide across the entire pedestal. The total detection distance is limited by the parameters of the RF system, so it can be assumed that we will install the hybrid system at much greater distance. This is possible only if we accept detection hole for RF technology or use a larger RF tags. But the point of the hybrid system is not to compete for the biggest detection. It's not even our goal. The task of the hybrid system is to offer a solution in case of migration from one technology to another, or for applications where the use of both technologies is advantageous at the same time. For now, that's all about the AM-RF hybrid system. I know this video can't provide all the details and informations. If you need more questions answered, please contact our technical support. Vladimir says goodbye.